Hello, in today's video we're going to be discussing section 8.4, which is on graphing quadratics in what we call vertex form. And our essential question is, how can you describe the graph of a function in the form f of x equals a times the quantity of x minus h squared? First off, I'd like to go ahead and graph the function x squared. So we do know that this is a parabola. We know that we haven't moved it at all to the left or to the right. So my vertex is going to be here at the origin. Once we find that vertex, we can then follow our pattern, which was left 3 up 9, left 2 up 4, left 1 up 1, right 3 up 9, right 2 up 4, and then right 1 up 1. So left 3 up 9, left 2 up 4, left 1 up 1, and the same thing on the right, because our graph is symmetric. And then we sketch our graph, and it's going to look something like that. Now, to graph the function g of x is x squared plus 4, we still follow the same pattern because the 1, our a value, is still the coefficient on x squared, but we have a plus 4 now. So I'm going to go ahead and create a little chart. We haven't moved this at all to the left or to the right, so I know that my vertex is going to be on 0 for x. I just don't know where it's going to be for y. And I'll plug in a couple numbers to the left, so -1, -2, and a couple to the right. Plugging in a -2, -2 squared is 4 plus 4 is 8. -1 squared is 1 plus 4 is 5. 0 squared plus 4 is 4. 1 squared plus 4 is 5. 2 squared plus 4 is 8. So I then go ahead, I'll do this one in red. -2 and 8 is going to be here. -1 and 5. 0 and 4. 1, 5, and 2, 8. And I want to compare the differences between these two graphs. So looking at each of these points, I used to have a 0, 0, now I'm at 0, 4, so I went up 4. At 1, 1, this point got moved up 1, 2, 3, 4. So instead of -1, 1, -1, 5 is my new point. So we just moved it straight up 4. -2 used to be at 4, but now we moved it up 1, 2, 3, 4. So we shifted that point up 4, and same thing on the right. So to compare the two graphs, all that happened is that all points in the function f of x were shifted up 4 to obtain g of x. So then looking at our two equations, I have f of x equals x squared, and then I've got g of x equals x squared plus 4. So the only difference in the two graphs is that plus 4 after the x squared. So it appears that that plus 4 seemed to shift the graph up 4. All right, so I want to go ahead and try this again, graphing the function f of x equals x minus 3 to the power of 2. So that -3 we know is going to shift our graph to the right 3, giving us a vertex of 3, 0. So I go to the right 3, up 0, and then I look at my a value, which is 1, which means that my pattern isn't going to change. So left 1, up 1, left 2, up 4, left 3, up 9, and then the same on the right. Right 1, up 1, right 2, up 4, right 3, up 9. So left 1, up 1 from the vertex, going back to the vertex. Left 2, up 4, back to the vertex. Left 3, up 9, back to the vertex. Right 1, up 1, right 2, up 4, right 3, up 9. And your parabola is going to look something like this. So now, just like before, I have the same equation, x minus 3 all squared and x minus 3 all squared, but in that second equation, g of x, I also have a minus 5. So just like before, where the plus 4 shifted my graph up 5, this minus 5, up 4, excuse me, this minus 5 is going to shift my whole graph down 5 units. So I'll graph this one in red. All I'm going to do is take every single point and go down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And same thing on that right hand side. So my parabola is going to look something like this. So compare the two graphs. F of x shifts down 5 to obtain g of x. Negative 5 or minus 5 shifts graph down 5. All right, we've got a couple more. I'm going to go ahead and walk us through the standard form of vertex form, and then we're going to continue practicing. So A is your multiplier that tells you what your pattern is going to be. It also will tell you your vertical stretch or vertical compression, meaning how wide or narrow your graph is going to be. So vertical stretch / compression. You can think of this kind of like slope. It's somewhat similar in that it tells you how steep or flat your graph is going to be. So I'm going to say this determines the pattern. H is the x value of your vertex. This tells us how much we are shifting to the left or to the right, and K is the y value of the vertex. So with that information, I'm going to go ahead and rewrite this function, h of x, so that it matches the form that we have above. So h of x is equal to 2 multiplied by x. And then I have minus h, so minus, and then we would be subtracting a negative 3 to get a positive 3 inside those parentheses, which means that my vertex is negative 3 for x and negative 6 for y. So I'm going to start by putting that on my graph, negative 3, negative 6. And then from there, I use my 2 to determine my pattern. So left 3, up 9, left 2, up 4, left 1, up 1. And then on the right, right 3, up 9, right 2, up 4, and right 1, up 1. But multiplying by 2 changes all my ups. So instead of up 9, I'm going up 18. Instead of up 4, I multiply by 2 and I'm going up 8. Instead of up 1, I multiply by 2 and I'm going up 2. And the same thing for the rights. I multiply all of those up directions by 2 to get my pattern. So then left 3 up 18 is going to be off my graph, but left 2 up 8 will be here. From my vertex, left 1 up 2 is here. And we are symmetrical, so the same on the right-hand side. Graphing my parabola, it's going to look something like this. And lastly, my axis of symmetry is going to be the vertical line going directly down the middle of my graph. This point, my vertex, has the coordinates negative 3, negative 6, so we know that this x value is negative 3. And it never, ever, ever changes. So my axis of symmetry has the equation x is negative 3. And we are done. Right, go ahead and take a moment, identify your a, h, and k values, and graph your function after pausing the video. A here is negative 3, x is going to be positive 2, and k is 4, which means that my vertex is at the point 2, 4. My axis of symmetry is going to be x equals positive 2. So 2, 4 is here. And then my pattern is going to be multiplied by a negative 3. So left 3 up 9, left 2 up 4, left 1 up 1. And rights follow that same pattern. and we multiply by a -3. So instead of up 3, I'm going down 27. Instead of up 4, when I multiply by -3, I'm going down 12, down 3, down 27, down 12, and down 3. So left 3, down 27 is way off my graph. So then I go left 2, down 12, left 1, down 3, right 1, down 20, right 3, down 27, which is off my graph, right 2, down 12, and right 1, down 3. So my graph is going to look like this. That vertex is at 2, 4, and my axis of symmetry is on the line where x is equal to 2. And we are done. All right, go ahead and pause the video and try this next one on your own. My vertex is at -5, 6. My parabola does have a -1 for that value of a, meaning that it is going to be facing downward. And my graph is going to look something like this. And that axis of symmetry is on the line x is -5, so we have a vertical line going directly through that vertex. All right, one more for you. Go ahead and pause the video again and practice this third one. My vertex is at +7, -8, so my axis of symmetry is at x is 7. So +7 and -8 is going to be here. And then my pattern, I multiply all the ups by 4, so right 1 up 4, right 2 up 16, and then right 3 is going to be way off my graph. And since we're symmetric, I have the same on the left-hand side. Oops, I think I can do better than that. Maybe not. My graph is going to look something like that. All right, 2 more to practice. Make sure you are confident and have mastered your topic, and then we will wrap it up for today. So go ahead and pause the video and try these last 2. All right, so your parabolas should look like these below. I've got an axis of symmetry for 5 in my first parabola, and then an axis of symmetry of -2 in my second parabola. All right, that brings us to the end of our video today. Thanks so much for watching, and have a great rest of your day.